Hey folks, how's it going? This is a little video that I decided to put together about synthetic division, all right, that I hope will maybe give you a little bit of background and provide you with some examples that I worked through and also some examples for you to work through, all right, with some solutions put together by me. Now previously I made a video about and we discussed polynomial long division, which in a sense is using some of the principles that you use with arithmetic long division to divide a polynomial by another polynomial. Okay, we looked at all kinds of examples of where this works, right? From dividing something like with just an x into something, and we even saw that it works with x squared. Now when I show you synthetic division, we're going to continue to boil it down and we'll look at some scenarios where it will work, but also we're going to want to think about what are the limitations, all right? Because every method has strengths and limitations, all right? So to start, when we think of synthetic division, well, when you think of the synthetic, right, we usually think about fake, okay? Synthetic motor oil is like not really fully motor oil, right? It's fake, okay? But not fully, right? So synthetic division is similar in idea to that. And let's take a look at first what a problem would look like with polynomial long division, and then how would it translate over to synthetic. Okay, so last time I showed you this problem here. We said, what is x cubed, okay, minus 4x squared plus 2x plus 5 divided by, all right, x minus 2. Okay, and I'll go ahead and walk through how we do the traditional long division so we can take a look at where would synthetic come into play. Okay, so first I set up my division and I fill in my divisor, and now I'm filling in my dividend. Okay, and so to start, we do the leading term, and I like to show what those are. Leading term. Okay, so what times x equals x cubed? That is 1x squared. And then I go ahead and bring that in. X cubed minus 2x squared. Okay, and then I do my subtraction. These cancel. And remembering, you got to be super careful because -4 minus -2, got to be super careful with our signs. Okay, then I repeat it again. So now this is my leading term. Okay, and I get minus 2x. All right, I bring that down, minus 2x squared plus, okay, and in this case, be careful, it's a -2 times -2, positive 4x. Okay, bring things down. And then lastly, and again, don't forget to do your subtraction because that sometimes prevents those weird sign errors. You might have thought, wait a minute, am I adding? But actually I'm subtracting because I'm subtracting all of this, all right? So then finally, do my last division. Okay. I get a remainder of 1. Okay, and how we write it is just like this. Okay? So what did I do here, right? I went leading term divided by leading term, multiplied, subtracted, and went all the way down. Now, this can be difficult for a lot of people for a few reasons. One, there's a lot to keep track of here. We need to keep track of division over and over. We need to keep track of our terms up here. We need to keep track of subtraction. And a lot of people find that division and subtraction are not their favorite operations of all time. All right, and to those individuals, I would not blame you. But if you take a look at it, really all we had to think about mostly to get these answers is we really were focused not so much on the power of x. You can see that the power of x will start at essentially the biggest power here minus the biggest power here. So it's 3 minus 1 is 2. And it will usually be descending by 1 every single time, right? Now, again, that depends on how this is set up. But that's a general pattern, right? It starts with a certain amount and it kind of slowly descends over time until you get to a point where you can't do any more, and that's where your remainder comes in. But what you might have noticed is that most of this comes down to the coefficients, right? Noticing where's the 1? There's a 1 here, there's a 1 here. 2 and 2, okay? 2 and 2. So what if we could take this process, okay, and boil it down to just the coefficients? That is what we do when we're talking about synthetic division, okay? So now what I'm going to do is I'm going to show you, and let's box this off. I'm going to show you the same thing done with synthetic division, and you're going to find that not only is this going to take up less space, but you might find this is a lot better method. Now, before I go ahead with this, you got to be careful not to get too wrapped up like, whoa, this is really efficient, because remember, there are going to be a couple little things that make synthetic division not necessarily the most ideal. You got to start by remembering this long division always works. No matter what the case is, it will always work. It always delivers a clear remainder. So it's like the quadratic formula with quadratics, right? There's a number of tricks with quadratics that make it easier, but the quadratic formula always works. Long division always works, okay? And as we get farther along in this video, I'm going to show you why synthetic would not work in certain scenarios, okay? So this is synthetic. So the first thing I'm going to do with synthetic is I'm going to take all of my coefficients of the dividend and I'm going to write them in. So I've got 1, -4, and the signs matter, 2, and 5, okay? And that represents x cubed, x squared, x number by itself. Now I'm going to draw this little thing here, almost like I took my division sign and I flipped it upside down. Now, the number I'm going to put up here is I'm going to put the number 2. And you might ask, well, wait a minute. You had a -2. This is a +2. The number I'm going to put here is essentially whatever makes the divisor 0. So plugging in 2 makes this 0. So you can think of it as like the root of the divisor. Okay? And now here's what I'm going to do. I'm now going to go ahead and I'm going to do some synthetic. So the first step I'm going to do is I'm going to take the 1. I'm going to bring it down. I'm going to write the 1 under there. Okay? Then I take the 1, I multiply by 2, I write the 2 underneath here, and then I'm going to then repeat the process. Now note before I continue, notice that 1 here is with 1 here. What is the 2 coming from? Well, when you think about it, when I do the division over the division, right, this is representing the leading term over the leading term, right? But remember, when I do long division, it's not just the original leading term that I'm multiplying. I'm also multiplying by whatever else is here, and then I'm subtracting. By flipping the sign, what I'm doing is instead of subtracting a positive, I'm essentially adding a negative. So I'm doing a similar thing because I'm going to show you what this is. Now I'm going to add, right? So this is going to give me -2. So here, I'd be subtracting, but here I'm going to flip the sign and add, right? So instead of subtracting a -2, right, I'd be adding a +2, and that's the same thing, right? Okay, notice again the -2 and the -2. Now, similar idea. I take the -2, multiply, I get -4, okay? Observe here, right? Well, here I was adding 2. Here, notice what I'm doing. When I add, I'm actually subtracting. Similarly here, when I add, I'm subtracting, okay? And finally, take that, multiply, I get -4, add, and I get 1. And I like to box off this 1 at the end because remember, this is the remainder. Okay, so again, this is what we get. Now, the last thing I've got to do is I've got to translate this, okay? So, my powers of x are always in descending order. So this is x, this is with nothing on it. This is with 1x, and this is with an x squared. So x squared minus 2x minus 2, and then I do my 1 over my x minus 2, okay? Sorry, I'll just move that up so you can see how I translated that over. All right, so some quick similarities to show you again. Observe, okay? The leading term over the leading term, okay, that's more or less represented when I'm doing this bring down, this addition here, okay? Because notice again, when I'm doing this subtraction here, that's going to control the new leading term, right? Just like when I do this addition, that controls the new leading term. Okay, notice how the number I'm dividing, well, what's this number in front of x? We don't see a number, it's 1. So the number in front of x in the divisor, the coefficient, you know, that's not going to have any impact, okay, on the coefficient of the quotient, because you're dividing by 1, right? And that's not going to ever affect anything. All right? So notice a couple other things. Notice the 4 and the -2. Okay, similar thing, except instead of subtracting a negative, I'm adding a positive. Same idea. Observe here, okay? Notice it's basically the things that are not canceling out. Notice the 2 and the 4. Okay, I'm subtracting a positive. I'm adding a negative. Okay? Then when these cancel out, notice, again, I'm subtracting a positive. I'm adding a negative. Okay, so there's a lot of really close correlation. And what we're doing here is what I've done is I've boiled it down, right? I've boiled this down to, instead of doing division and subtraction, I'm doing addition and multiplication, okay? And a lot of people tend to find that addition and multiplication are easier, and so that's why this turns out to be a little bit nicer than long division when it is usable, okay? That's the catch, when it's usable. Okay, so what I'm going to do right now is I'm going to show you another example a little bit quicker on how do I do synthetic. And I'm going to start by showing you just one where we can just shoot right through this as is, no funny business. All right, so here we go. This is, again, one that I showed you last time. If you want to go back, look at one of my older videos on polynomial long division, that's where you're going to see me do this with long division. So previously, I did r squared plus 14r plus 38, okay, divided by r plus 8, okay? Now I'm going to show you with synthetic division. So first, set it up. Put my little remainder on the end. Now, inside, let's go coefficients. 1, 14, 38. Okay? And over here, I put my -8. So I do it again. Bring down the 1. Multiply the 1 by the -8. Okay? Do 14 minus -8, or rather 14 plus -8, because we're adding. That's going to give me what? Well, that is going to give me a number that is 6. Okay? Take 6 and multiply by -8. I get -48. Add up 38 and -48. I get -10. Then I come down. I do my 6 plus x. Some people like to do it the other way, and that's understandable. And plus, bring in my remainder, -10 over r plus 8. Okay? And there we go. That, you might have noticed, was a whole lot faster than when I did it with the long division. You might see me take a couple minutes to do that out, but I got that out really quick with the synthetic division method, and I got the right answer, all right? Again, if you watch the other video, except the only thing that I would do differently, and I know even I get tempted to use the x, is please do put everything in the same variable. So that was my mistake there as well. Make sure you put everything into r's. All right, we all make that mistake, totally understandable, but keep it in the original variable, right? I know some of us like to, x, that's what I'm comfortable with, but sometimes it's okay to break out of your comfort zone. All right, so if you need to watch me do that again, go ahead, rewind it, and it's really worth taking a look at that example. And then in a second, I'll just go ahead and I'll kind of jump back in, and I'm going to show you 2 scenarios where we might run into some problems. All right, so here's the thing. I'm going to now show you a couple quirks with long division, synthetic style. And here's going to be my first quirk. I'm going to show you something that this also threw me off in my first video originally, and I had to kind of go into a little bit of a further explanation on this. So what I have is 2x cubed plus 4x squared minus 5 over x plus 3. Okay? Now, if you take a look at this problem right here, notice a difference. Compared to my last problem, there's no x. So when I do the long division with synthetic style, I have to be careful. When I did it with traditional long division style, I said, remember, and you might want to go back and take a look at this video, remember to put in the 0, okay? Because that helps you keep things nice and organized. The same thing is what you have to do here, okay? So you start with, how many x cubes do I have? 2. How many x squareds do I have? 4. How many x's do I have? 0. If you don't put in this 0, this will mess up everything. This will throw everything off. You have to put in a 0 wherever there's a 0, okay? And then minus 5, okay? Again, super duper important. And then again, what's gonna make this 0? Negative 3. Okay, so again, now that I do that, I bring down my 2. I multiply 2 by negative 3. I add, okay? I multiply 2 by negative 3 again. Now this one you got to be careful. They're negative, so this will become a positive. Positive 6. Multiply again, negative 18. Add negative 23. So that gives me, okay, be careful. So this is nothing, x squared. So I get 2x squared minus 2x plus 6 plus negative 23 over x plus 3, okay? And this is, again, the exact same answer I got in the other video, but just be careful here. Again, the 0 means everything. All right, now some people like to take a look at this like this. Some people like to look at it like a bus, all right, where here's your bus driver, here's your little remainder wheel, and these are all the kids. And I heard a really good analogy. Well, what's happening? Someone's missing. We got a sick kid. No one's sitting in that row, all right? So we got to really, whatever it takes you to think about that, we got to do that, because this is one of the ways that things start to get messed up concerning this method, okay? If I had dropped this 0, what would happen is I would have taken this negative 2, hit the 3, and I would have been done, and it would have looked right, but I would have actually left off a whole term. I would have been way, way, way off, okay? So it's really important. Now, if it helps you, maybe think about rewriting. So, oh, I don't see a coefficient. Maybe start by rewriting this, okay? These are the exact same thing, right? All I did is I just substituted, I put in a 0 to remind myself, get that important like visual cue, because again, that's what messes something up. So that's one area where things can get a little bit sticky with synthetic division. Here's the other area where things are gonna get sticky with synthetic. And this is gonna be your big downfall where things are not gonna work out well. Suppose I want to do the following. I want to do 2x cubed minus, or how about this, plus 7x squared minus 4x plus 7 over x squared plus 2x minus 1. Here the difference is it's not just an x anymore, it's an x squared. And because of this, synthetic is not what we're going to use here, okay? And just to keep it simpler, it's just not something I'm going to do. The reason that it doesn't really work is notice how I've got 2 rows here. The 2 rows has to do with the fact that every time, remember this is an x plus 3, so if we go back to what we know about long division, well, this has to do with the fact that I'm always multiplying by 2 things. The x, like when I get my leading term over leading term, I always multiply that by x, and then I multiply it by 3, okay? That's what the negative 3 kind of represents. Here, it's a different issue, because now when I do leading term over leading term, first I do it by x squared, then I do it by x, then I do it by 1. So that makes it complicated because then I'm not multiplying by one thing, I'm multiplying by two things, okay? So in these cases with the x squareds, I'm going to say stay away from that. That's going to cause a lot of issues. So that is where you'd use maybe long division, or you might have seen like the area method in reverse. That might be a strategy you want to use, but you cannot in this case and should not use the synthetic division method in order to do this, okay? Again, you gotta heed those kind of warnings. That's going to be important. All right, now to wrap up, I'm going to show you two U-try problems that I want you to try to do on your own, okay? And here's what they're going to be. First, what I want you to do is x squared plus 5x plus 3 over x plus 6. I showed this problem on the last video with long division. I want you to try to do this with synthetic division. Okay, this is just a quick, hopefully straightforward one. Now I'm going to show you another one where I'm going to do r cubed. Let's see if I can do this. Ready? Plus 3r squared plus, how about 5? Okay, and sometimes it's not always good to make an example up off the top of your head, but it's all right. Let's see what happens over r minus 2. Okay, so take a second, try to do these out with synthetic division, and then in a second I will go through and explain to you how to do each one. Okay, so again, pause your video now, and then go ahead and try these on your own, and then I'll jump in and show you how to do the solutions. All right, here we go with the solution. So again, take a look. Put in your -6, because this is going to kill that one. Boom. Then coefficients come down. 1, 5, 3. Okay, make our bus. Here's our back wheel. And the back wheel really should extend to the 3, because that's going to be basically our last step. That's the last thing we can bring down. So the 1 comes down. In this case, 1. Okay, times -6, we get -6. Atom, -1. Multiply out again. Okay, being extremely careful with how you're doing it, right? Because when you add the -6, important to get the -1. Okay, now it could be tricky, but we got this. -1 times. Now I almost did the -6, but remember, you always are multiplying this number. That's where the +6 comes in. You add 3 and 6, and you get 9. So our answer is x minus 1 plus 9 over x plus 6. And that's all we can do on that one. Okay, so again, if you need a second to maybe wind that back and take a look at it, go ahead and do that. And then in about 5 seconds, I'm going to go ahead and move forward to the next one. All right, last one, let's get it. So we got r minus 2, drop in my 2, set up my bus, ready, r cubed, 1 of them, r squared, 3 of them. Now wait a minute, remember what's missing? There's a sick kid. No. Okay, and here's the thing, just a quick refresher. Let's say I had done r cubed plus, I don't know, 6. Okay, then you'd have to put in a 0 for the r squared and a 0 for the r. Okay, so that's important to think about. Okay, every time there's something missing, you have to put in that 0. That's really, really important. Okay, so coming back to here, here's my setup. 1, 3, 0, 5, and I bring it down. Let's get it. So here we go. 1. 1 times 2 is 2. 2 plus 3 is 5. 5 times 2 is 10. 0 plus 10 is 10. 10 times 2 is 20. 5 plus 20 is 25. Okay? So now to interpret, that means is my final answer is r squared plus 5r plus 10, and then the remainder of 25 over r minus 2. Okay, that's going to be my final answer here. Okay, and again, all I'm doing is step-by-step synthetic division. All right, so again, synthetic, 2 big things that we want to take away. 3 big things, actually. 1, only thing that matters here are going to be the coefficients. In the top, the coefficients are the only things we use when we do synthetic division, and then whatever makes this 0 goes on the outside. That's basically number 1. Number 2, synthetic division, not going to work in the situation where your divisor is a quadratic. We want to pull back. We want to say, wait, let's go ahead and do another method. So though it's efficient, that's going to be your con. Doesn't always work. Last big thing, whenever you see a 0 coefficient, you have to drop that 0. Here and up here, you have to drop that 0. If you don't, everything's going to go haywire from there. Okay? So again, I'll write it out. 1, okay, use coefficients. 2, x squareds and above for divisor, no good. Okay, get out of there, no good. Last, remember 0 coefficients. Okay, that's really important. If you don't drop those zeros in, I hate to beat a dead horse, but that's something we got to remember. Okay, so I hope you found this video to be kind of educational. I hope that you got a little bit more information on how do we do the synthetic division. If this was something that was confusing for you, I totally understand. Although there are backgrounds with what we might know in the past for how this division stuff works, it is by no means obvious, and to the newcomer, by no means intuitive necessarily on how do we do this stuff. All right, so again, I really hope you enjoy this. Please feel free to go back and look at anything I did, whether that be the you try examples or the examples I did. But remember, you can do it. All right, so again, keep learning, keep watching, believe in yourself, and then keep enjoying math. All right, thank you very much. Have a wonderful day.